Hello, and welcome back to part 2 of my 2024 Commodore 64 Repairathon. We're going to work on machine 4 today, and unfortunately that's it. This machine was a roller coaster ride. It's also a cautionary tale, so keep an eye on what goes on, and I know I learned a lot from this. Things to do and things not to do, and I think there's a possibility you could benefit from it as well. So watch for what goes on. Now this machine, it takes me everywhere. I'm obviously recording this after the fact, so I know what goes on. There are some bad parts on the board, so we fixed those. Those are relatively straightforward. There is some questionable rework that was done by a previous owner that we have to clean up. We do end up finding out that one or two of the parts that I try to replace other parts with are not quite what I expected them to be. So you'll learn about that. That happens near the end, actually. And I make some of my typical stupid mistakes. One of the mistakes I made was fairly catastrophic, and the other one just cost me a whole lot of time and energy. So let's get down to it. Okay, before we get started with machine number 4, I do have some updates on the machines from the first video. Machine number 1, which needed a new VIC-II chip, has received it. I got the 2 VIC-IIs that I ordered in the mail, and I tested both. Both are working, and I put one of them in machine number 1. Machine number 1 is now fully operational. Machine number 2, as you recall, is missing all of its chips. They've been plundered. So that will only get fixed if at the end of everything else we have enough spare parts to do that. Machine number 3, we had 2 7708 MOS branded logic chips that we swapped out. The one in U13 didn't fix the problem, but the one in U25 did. And if you remember, I promised I would test those in the TL866 programmer, and it actually turns out that both of them were bad. So those will go in the dead parts, and if you recall, we replaced those with brand new 74LS 257 chips. So those are good. The next update I have is on the SIDs.
Hi ho, me from the future here. I bungled this section, so let's get it right. I accused 2 SIDs, the one in the ZIF machine and the one in machine number 3, of being marginal or starting to go bad. I had heard some strange audio artifacts and jumped to the conclusion that it was the SID. I was wrong. While editing the video, I didn't hear the same weird artifacts. Further testing revealed that the problem could actually be traced back to how I had my monitoring configured for the direct audio capture. Once I fixed that, the SID sounded okay. I hadn't replaced the SID in the ZIF machine. I was going to let it go until it got worse. I did, however, replace the SID in machine number 3 with an ARM SID. I've since replaced the original SID in that machine, and it's sounding fine. And one final update that I forgot to mention, the PLA replacement that I used in machine number 3 is actually a Plankton EV. This is an updated voltage-accurate version of the original Plankton.
And this is machine number 4. As you can see, it's dirty, but it doesn't appear to be very yellowed. Again, I don't think I will have to put this through a retrobite stage. It does have one broken keycap, the number 3, which was in the tote, so I do have that, and I can, it looks like someone has previously tried to super glue it, but I can replace the key stem and put that key back on, so we're in good shape there. I don't see any damage to the case. Everything looks good. It does have what appears to be a jack on this on the left-hand side. I'm not sure what that's for. We'll have to take a look at that inside. We have a note. It says power light, black screen, 9516. So looks like there was power. It has an OK in 427.93, but a black screen by 2016. So we'll go ahead and verify that black screen in the power light. Hooking up to the output and the bench power supply, which is switched on, and switch over to output mode. And let's see if we get anything. We do indeed get the power light. However, I am getting no video out, so we may have another dead VIC-II. All right. Well, we won't get anything by putting in the dead test at this point, so our only option is to open this thing up. We're missing 2 of the screws. Obviously, I can fix that. We do have the 1 screw in the middle. And what do we have when we open her up? And it is yet another 250425 board. Looks like we had what was probably a reset switch. A reset switch is what this little hole in the side with the grommet on it's for. But that reset switch seems to be, or button seems to be gone. So we'll just remove that. It's a soft reset, not a hard reset anyway, so it's not the best way to do a reset on a Commodore 64. And let's go ahead and see about getting the shield off. And what do we have? Standard 6581 SID. We have all the chips. We do have a couple of Moss branded Logics in sockets. We have 1 RAM chip in a socket. We do have MT RAM, so those are going to be highly suspect. The multiplexers are not Moss this time. And the PLA is an 82S100. So likely that PLA is good. But like I said, everything's in sockets, so what I'm going to do, this is an R9 VIC chip, which are uncommon. You don't see them often, but it's a shame if it's dead. We could have a power issue. But let's pop the VIC-II, and I want to test this PLA since it's in a socket and it's an 82S100. I want to test it in the ZIF board. We can test everything else later once we start getting a video out. So, ZIF board. Make sure it's still working. And it is. So, our first test is the VIC-II. Is this 6567 R9 VIC-II bad? No, it is not bad. So that's a very good thing. So our VIC-II is good. Now let's check this PLA. As I said, 82S100s are not common, but they are relatively reliable. So let's see if the PLA works. And yes, it does. So we've got a good PLA and a good VIC-II. That's a good start. Okay. We will set the ZIF board aside for now. Probably have to come back to it. But let's... We will first check the voltages, and we're going to start with the 2 voltages being created by the bridge rectifier caps and the regulators on this side of the board that come from the 9 volts coming in from the power supply. So this should be 5 volts, and it is. This should be 12 volts. And it is. So we've got good voltages there. Check our 5 volts. I never remember which one's which. Is this the 5 volts? That's, yeah, I got it backwards. That's 5 volts, but it's reading a little low on the user port. And then read our AC voltage on the user port. That is reading 10.25, so that's good. So our voltages are actually good. So why aren't we getting video? I need to put the PLA back to do anything. Okay. Our VIC-II, which tested good in the ZIF machine, should work if everything down here is okay. Well, let's put the VIC-II back in. It is possible that was just a bad connection, and taking it out and putting it back in might fix it. We'll see. No, I'm still not getting anything. So, going to have to scope some signals. On the 6567, let's look for VCC, that's pin 40. That's 5 volts, that's what it should be. Let's see. So that makes more sense. At 5 volts per division, and now we are seeing. Sometimes I make silly mistakes. I had the range on the scope set wrong. So at 5 volts per division, we are seeing a good 12 volts at the VCC pin. Now, let's look at pin 17, should be a clock. It is, let's see. There is a teeny tiny signal on 50. I wonder. I'm going to try replacing the 8701. This is a clock generator IC that replaces a lot of the logic that used to be in these cans. There were a lot of chips and caps and resistors and things, but Commodore combined a lot of that logic into the 8701 clock generator IC. Let me see if I can find, I know I have more of them. I do indeed have some more 8701s. So let's go ahead and seat one of these replacements. Let's see if that doesn't get us a better clock. All right. Anything? Yes, we have improvement. We're still messed up though. but we're at least getting video signal. So the 8701 was bad. And now, why do we have corruption in that screen? That looks like an addressing fault. Well, we're going to try at this point dead test. Okay, this should be dead test. Let's see what we get. We get 2 flashes, so we have a memory problem, which again could be something damaging the address bus, but we will take a look and see which chip is 2 flashes. Okay, as you can see from the diagnostics manual, 2 flashes on this board is U24. U24 is going to be this IC right here. Again, these are all MT RAMs except for the one in the socket, so I would not be surprised if U24 was actually bad. So we're going to go ahead and take that out and replace it with a socket and a new 4164 DRAM IC. At the same time, we'll go ahead and remove the remnants of this reset switch just to get that out of the way. Whoa. Whoa. I may not need to do that after all. I have just found something horrific. Or at least possibly horrific. I don't know if you can see this. Those pins are a mess. I don't know what is on there. I have no idea if this chip is working. What is U14? U14 is a 74LS258, of which I have spares. Now that's also a MOS logic chip in this board. It's a MOS 7709. Okay. Here is a brand new 74LS258, and we're going to put it in where the damaged 258 was and see if that doesn't solve our problem. It looks like the 258 is doing some address demultiplexing, so we could get lucky here. And let's see. Well, will you look at that? That was the problem. So that looks like it fixes the board. Let's run it through some diagnostics and see for sure. Here's dead test again. Nope, dead test is still telling us there's some bad RAM. So we do need to pull, and that's still the same 2 flashes, which is still U24. So we're still going to pull that out, but we're definitely closer, and I'm glad I noticed that. A visual inspection of the board might have shown me that, but I didn't see it. So quick visual inspection now. We still have one MOS logic chip, the 8712. Not sure what that is. So that's in U27. Out of curiosity, what is U27? U27 is a 74LS08. Just to play it safe, or just to see, I am going to pull that MOS 8712 and put in an actual LS08.
This would prove to be a mistake, though past me won't figure that out until near the end of the video.
This may be useless, but it's always good to get rid of those MOS logic chips. Brand new 74LS08. And dead test. Anything better? Nope, still 2 flashes. Okay. We'll leave that MOS logic chip out. Okay. So now we need to pull U24. Warm up the desoldering iron. Oh, we definitely had some rework here, and whoever did it didn't clean up after themselves. Okay, remove Smurf poo. And a new 4164. This one's been tested and good. And let's see if we accomplished anything. Still on dead test. Hey! Alright, let's see how far we get. I think there's still a problem. Oh no, it's moving. We got a problem with color. I can see that. The top part of the red box at the bottom for the memory is partially blue, so there's an issue there somewhere. This will also be our first chance to see if the SID is working at all. Working, but not working right. So that one definitely is marginal. That wouldn't be caused by my audio setup. And we're not getting any reports telling us why we're getting that weird color. Let's see if we just bring it back up again, if it's any different. No, it's still off. Okay. Let's see if we can get any further information by going over to the regular diagnostics. We'll try it without the harness first. Weird colors. Yeah. Our SID is definitely not good. So let's go ahead and pop that out. Arm SID this sucker up. And attach the harness so we can see what's going on everywhere.
Things are about to go catastrophically pear-shaped. And I'm pretty sure it's because of something I'm failing to do right here.
It's interesting. The harness on, I'm not getting anything. It's interesting. We're not getting anything at all right now. Well, we're going to have to see what's going on here. Well, that's rather annoying. I tracked down what happened, or at least I tracked down what was wrong. And it turns out I actually lost two ICs. I lost the kernel ROM, and I lost one of the 6526 CIA chips. Now, when put into the ZIF machine in the U1 position, which controls the keyboard, random characters come up. It functions, but random characters come up. And with the ROM in, nothing happens. So, I've replaced the CIA, and I've replaced the ROM with an EEPROM and a little adapter board. And we now have a working machine again, as you'll see here. Or at least as much of a working machine as we've got tested at this point. For an explanation of what happened, I can only guess. I can't go back in time and test and see what was going on, but I can guess what happened. And what I think happened was this. I was putting in the diagnostic harness. So most of us have heard, and if you haven't, here's new information for you. It often happens that when plugging things into the control ports, which are handled by one of the CIAs, an electrostatic charge can pass through that into the CIA and blow the CIA out. Now, in most cases, control ports are encased in plastic, so you don't have an electrical connection between yourself and the actual electronics because there's no conductivity on the plastic shell. So it's a rare occurrence when putting in a regular controller unless the controller itself is charged with static electricity. However, what I was plugging in was this. This is the control port dongle for my diagnostic harness. And as you can see, there's a lot of exposed conductive material here. So what I think happened was I was being my typical cavalier self and not thinking, and I was not wearing my anti-static strap. And I believe what happened was that I passed an ESD electrostatic discharge through this dongle into the control port, into the CIA, and blew it up. Now, as for the kernel, I can't be as sure, but I have to assume that since there are address bus and data bus connections between the CIA and all the other chips on the board, including the kernel ROM, that the electrostatic discharge made it to the kernel and zapped it as well. So that was on me. I did that. So what we need to do now is get back to where we were when we were about to run the full diagnostics with the harness. Now this time I am wearing my anti-static strap, so hopefully we won't blow anything else. So let's hook up the harness. Let's actually turn the machine off. Put in the diagnostic cartridge. All right, rest of the diagnostic harness. Serial port. Cassette port. User port. And the keyboard. Just FYI, I've never had that happen before. I have heard about it happening, but I've never actually had it happen while I was working on a machine. So like I said, I'm kind of cavalier about using my wrist strap. This is a lesson that I've learned. I'm going to try to make sure that I'm always using the wrist strap from now on. So let's see where we are with the diagnostics. Now we will get control port bad and 6581 bad because I do not have the, oh, we're still on dead test. I need to change that because the SID is not in the board. The ARM SID is not in the board. I wanted to run regular diagnostics, so I need to change the cartridge. This should be the full diagnostics. So we still have the problem with the colors being off, and that could be a color RAM issue. We'll have to look at that. It could also be some of the logic that connects the color RAM to the VIC-II. CIAs are working as they should. That is, the timers are correct. So as expected, we get control port bad and 6581 SID bad. So let's go ahead and pop our SID back in. And see if those are corrected. I might have blown the SID at the same time, so we may have a dead ARM SID. Well, let's... We'll set that aside for checking later. In the meantime, let's grab another SID. Try another fresh new ARM SID. See what that gives us. Okay, that fixes our SID problem. Now the only thing we have left is the color issue. Now, since the computer wasn't actually complaining about the color RAM, that implies to me that it's able to read and write data, but the colors are coming up wrong, so that implies to me that we've got an issue with addressing on the color RAM. So what I'm going to do is I am going to look up the schematic and see where the addressing is coming from and going through and see if we can figure out what's going on there. Okay, so I've been taking a look at the schematics and trying to see what chips might affect the addressing with respect to the color RAM. And there are four chips that seem to be in play. The first chip is the VIC-II itself, which, as you know, we've tested in the ZIF machine, and that's working just fine, and the colors are fine, so that's not the issue. The second chip is the 74LS258 at U14. That's this guy right here. And if you'll remember, let's see, I think it's right here. We've already pulled that chip because it had some pretty mangled up legs and replaced it. So that is not the issue. I even went ahead and pulled that chip back out and tested it in the TL866, and it is testing good. The third chip that's involved is the 2114 itself, the color RAM, the static RAM for the color RAM. That obviously has to do with its addressing because that's the chip we're talking to. So I went ahead and swapped it for another 2114, and there was no change whatsoever. The colors were in different places, but that's probably down to whatever is stored in the static RAM at boot up. It might be different each time, so the location of the colors would be different. So the color RAM itself isn't the issue. The final chip that's in play is the U2674LS373. Now that is a octal latch, and that's used to drive the data bus, or the address bus. So I took a look at that with the scope, and nothing seemed out of place. There were no half signals or anything that you would expect to see on a chip that's simply going bad, and the drivers are no good anymore. So, still suspecting it, I went ahead and hooked up my logic analyzer. And this is part of the trace that I received. Now, to understand this, we have to understand a little bit about how this chip works and what I've got hooked up here. We have an output control, which is an active low signal. So when this signal is low, which it is in this segment, the output drivers are enabled. Then we have a C signal, which I don't know what C actually stands for, but depending on the version of this chip, that can be either C or clock. At any rate, what that does is when it's high or active, the output with the Q should follow the input, the D. So during this segment, while the C is high, output should follow input. And as you can see, for the most part, that is the case. However, when it goes low, when C goes low, the output should be latched. In other words, it should not change from what it was at the start of the C being low phase. And if you look down here on channel 3, for instance, while C is low, we have a change. And that should not happen. Now, that could be an artifact of the drivers not being, the drivers being in a high impedance state, and that could just be an artifact of the floating signal level. But it does concern me, and it happens here in it happens on both channel 2 and channel 3. So I'm pretty sure, or pretty confident, that our problem is very likely this 74LS373. So we're going to go ahead and change it. Okay, here is our new 74LS374. Get rid of our blue tack. Okay. And give this a test. I'm betting it won't work. Oh, even worse. What did I do wrong? Didn't bend any pins. Didn't put it in upside down. Maybe we have a bad chip. No. Testing good in the TL866. Well, here's the chip that I just took out. Let's see if we can pop this back in and see if we can get back to where we were. Otherwise, I've made a mistake in my soldering. And there's the original chip back. Yep, that puts us back where we were. Oh. Ha! Okay, my mistake. 74LS373. 74LS373. There we go. Now what do we get? Probably the same color problems. Yep, that wasn't the issue. All right. So we have changed out the color RAM, the 373, the 258. I'm going to have to think about this. Okay, I have another suspect. This 74LS139 is a decoder. It decodes a 2-bit binary number into one of 4 pins. And it doesn't appear that it's outputting anything. It's responsible for the color signal that helps to select the color RAM, the chip select, and it's constantly high. It should go low at some points. So I think that chip may be an issue. So I'm going to remove it. The 139 that came out has rather corroded legs, and I don't know if you'll be able to see that. I think I'll give it a quick test in the TL866. It's testing good, so this is probably not going to fix anything. But we'll put in the new one anyway. And give it a test. No change. Apart from where the red is showing up. As you can see, we've tested or replaced most of the ICs on the board. These two are address multiplexers for the RAM. They really don't have anything to do with the color RAM. 4066s are not to do with addressing. I suppose it's possible that these MT RAMs could be one or more of them could be causing an issue. I just don't know. Okay, folks, I may have found the problem. I checked continuity on the address pins on the color RAM to where they're supposed to go to, and I found that pin 16, which is address line, I believe it's 8, is supposed to go to pin 32 on the VIC-II, and it doesn't get there. Strangely, it does get to the pin on the back of the board, which tells me that that socket has somehow there's a break in the pin that's not allowing continuity. So I'm going to replace the socket. Well, there's the answer, folks. Whoever put this socket in bent pin 16. It was never soldered through the board. Oh, frustrating. It was a lot of work to come to that conclusion. If this doesn't do it, I am giving up for the night. It is very late and I'm very tired. Let's see if this does the trick. There we go. All the colors in the right places. Okay, let's let this run through. Alrighty, so when we ran the diagnostics, you might have noticed that we were showing failures on the CIAs, both of them. In later tests, it would, well, sometimes it would show the keyboard bad, sometimes it would show user port, sometimes serial port. It was kind of random, and I'm not sure exactly why, but the problem turned out to be that on the keyboard connector on the motherboard, pin 20, the pin near the back of near the very back of the board, was bent out of place, and when I was putting the keyboard connector on, it was not going into the hole meant for it. So once I bent that back and put the keyboard connector back on, okay, now you'll notice that we are still showing one bad 6526, and the keyboard connector is in place right. The problem here, if you'll also notice, the timers, the time of day clocks at the bottom aren't running. And the reason for that, I can show you that here. If you remember, we had this MOS 7712 in U27 right here. And I changed that out. I think if I remember right, I put a new socket in it. Anyway, I changed it out for a 74 LS08, which I had in my stock. Now the problem with that, and it doesn't do it all the time, but it does do it some of the time. I'll let you see this here. All right. Now, I had trouble finding this because I was actually using the wrong schematic on Zimmers. There are two sets of schematics for the 250425 on Zimmers. This is the one I was looking at. If you'll notice, it's showing that U27 pins 1, 2, and 3 are being used for the clock frequency circuit. Actually, it is, as you can see here, the reality is it's 8, 9, and 10. So 9 and 10 are the two inputs and 8 is the output. So you'll see when this is running, and it'll probably be working this time, my luck, but our pin 10 is 5 volts, pin 9 is the squashed down 9 volt AC that goes through a resistor to bring it down, and then there's a Zener diode to clamp it, and then it comes into this chip. And this chip's job, this is a 74LS08, is a quad AND gate, positive AND gate. So if you take 5 volts, which is a 1, and this 60 hertz clock signal, which alternates between 0 and 1, and you AND them together, you should get a nice square wave coming out at 60 hertz. But for some reason, this chip that I got from my stores and several others, I'd actually tried several others and they were all the same, are not reacting to this clock signal. It's too low for it. It's going to just over 2 volts, and this chip is not registering that as a 1. I've seen this before. It's been suggested that these are 74 HC or HCT 08s, and those don't react the same to the same voltage level to give you the logics that you want. I did try acetone on this. It didn't wipe anything away, so I don't think it's a rebadged chip. I think it was manufactured this way. So what I did is I actually ordered some new ones from DigiKey, a reliable vendor. And first what I did was put back the 7712, and actually that works. But I'm not going to put a MOS chip back in here, so I ordered new 74LS08s from DigiKey, and I tested this earlier. It worked earlier, so let's hope it works now. So let's bring this back up again. This time I'm going to, well, yeah. Let's bring this back up again, and we'll look again. Our inputs. Pin 10 should be our 5 volts, and it is. Pin 9 is still the clock signal. It actually runs a little higher right now. And here's our nice square wave coming off of this, and that should be giving us our clocks. So if I switch over here to the output, you'll see the diagnostics running. You see the clocks are working. And no bad on either of the CIAs. So we now have a fully working Commodore 64 board for Machine 4. Finally. And of course, the last thing we always have to do. So there you go. And that will do it for video number 2 in the Commodore 64 Repairathon series. Come back in hopefully a week for number 3, and we'll see if we can get 1 or 2 more machines done. In the meantime, if you enjoyed the video, and I hope you did, a lot of drama in this one, give it a like, click that thumbs up button. If you haven't subscribed to the channel, you can go ahead and do that now, and click the notification bell if you want to get an alert when I post a new video. Leave me a comment below. I love getting comments from you guys. You were very generous with comments in part 1, and I'd like to keep that going here in part 2. It does me a lot of good to hear from you, and it also helps the channel out. The more you engage with me, the more YouTube will share this video out to more folks. Speaking of sharing, share the video to your social media and to your friends, anybody who you think might enjoy it. I'd appreciate that. And I want to give a thanks to my supporters. There are a few ways that you can support the channel. All of these links will be in the description below. There's Patreon. I also have a Ko-Fi account, and if you want to join the channel membership, there should be a button down here somewhere right below the video where you can join the channel membership. Those do offer a few small perks, and you're not required, obviously, to join to watch the videos. There may occasionally be some members only or patrons only videos, but for the most part, everything I do is public. And I think that'll do it for the day. So, everybody, stay safe and be well, and have a great week, and come back for the next one. We'll see you then. Bye.